A water particle of mass 10 milligram and having a charge of 1.5 multiplied by 10 to the power minus 6 Coulomb stays suspended in a room. What is the magnitude of electric field in the room and what is its direction? So now this is a much simpler question. So for this kind of question, the question is asking that there is a charged liquid droplet. In this case, it is given water. It can also be given in terms of oil being charged. So it is having a certain mass. It is going to exert a force equivalent to its weight, that is mg, in the downward direction. And if it has to remain suspended in the room, then it must be counterbalanced by the electrostatic force which is acting in the upward direction, which is equal to QE. So if these two forces equate with each other, so we say for equilibrium the electrostatic force must be balanced by the magnitude of the gravitational force, and hence we can write it as QE. So the water particle is having this we are asked, and the charge is given as 1.5 10 to the power minus 6 into electric field E, which is not known, is equal to mg. So it is important that we put the value in kg. So in order to put this in kg, we are writing it as 10 upon milligram, so divide by 1000. To convert gram into kg, again 1000, and then we multiply it by g. So we are taking g as 10. So if we put these values over here together, we find electric field as equivalent to 1.5 into 10 to the power 3 Newton per Coulomb. So let us move to the next question.